day to you. This is Anagalactic bringing you the next in series in our discussion of the collapse of the wave function. This will be the 11th video today that I've produced, and it should run about 10 to 15 minutes, I hope. The collapse of the wave function has taken so long to introduce because it's necessary, of course, to visualize in a presentation of this sort where I am not even showing you diagrams. It's because it's so utterly simple. The paradigm shift is in the interpretation of space. Clearly, space must be spherical. The phenomenon of gravity is spherical. In other words, it is a force. Sometimes that is contested, but from the correct perspective, it actually is a force. But what makes it so difficult to call it a force, it's not a Newtonian force. In fact, it's a monopolar force in space. So it has no real time component, and therefore it appears to bend space. Now that may or may not be an illusion from our present perspective. I already know the solution to this, but in order to see this, you actually have to see it directly, and then you see it makes, it's consistent. It's a coherent solution, but the important thing, in my opinion, from many vantage points, is that it's visualizable. I don't know if you have ever tried to visualize space-time. You can look at diagrams of a 3D projection, actually projected onto a 2D surface so you can see it, but with shading you can imagine 3D, but that's the most we can imagine. But then what you're actually forcing yourself to imagine a fourth dimension to space. It is a spatial dimension, but it's signed so that it's a non-positive, but it's polar. It's actually signed negative, so the number itself is simply the polar opposite valence. Now, all of that is just more bracketing information so that I'll have a means of introducing the collapse of the wave function in this video without referring to the videos that went before. But I will also be capitalizing on those videos that went before, amounting to perhaps an hour of careful preparation, so you'll be prepared for something that's so strange because it's so obvious. It's so simple, which can be deceiving. So this is actually something that your mind may not actually want to accept because it does contradict the current perception of space-time, which is pseudo-hyperbolic. Without going into that, because that would take us a bit far afield to explain what I mean by that, it's inside-out spheric. It's actually spherical, but it's inside out. But that's actually not the major flaw. It technically need not be a flaw. It's simply a different mathematical construction. But why can't it be spheric when it actually physically is a spherical phenomenon? Speaking of gravity, the reason I bring in gravity is because it gets you to picture the fact that when you're talking about a force in space, you have to be specific that it is actually operating on space. So gravity is actually changing space. That's why space-time is said to curve, which is an incorrect statement. Only space curves. If you're just considering gravity, in relativity, you're not considering just space. That's the whole point. So gravity takes on a peculiar characteristic, which it doesn't really have, because you're conjugating space with time in order to curve space. But when you do that, you're also curving time. And that produces a strange invert. It's called hyperbolic because it's actually a variation of spheric, because the family of hyperbole are curved. They're curves. They're pure curves. Well, of course, so is a sphere. That is a pure curve. But the surface of a sphere has what is called a convex surface, which is actually a linear term, but what it means is there's an inside. In grid space, which is 4D spacetime, is a grid. You have hypercubic numbers. You have a 4-component number, where a single component number is simply a linear number because it's on a line. A 2-component number would be an XY coordinate on the plane. A 3-component number, these are 3 linear numbers that are in relation. They're orthogonal, which is why you use the square law even in spacetime, where you sum the squares and then take the square root of the result, because you're adding squares together to get another square, which is rather peculiar when you extend it beyond the obvious Pythagorean theorem. You really do the same thing in spacetime. You can do the same thing in 3D space. It does lead to mathematical problems, but those are subsidiary to what we're trying to get at, which is the collapse of the wave function, which I've described to you already in terms of entanglement, and I actually didn't give a very good transition. That may have been rather abrupt. In the prior video, I was talking about the collapse of the wave function, which refers to the photon. But it doesn't have to refer to the photon. It also refers to what might be called a general class of wave function collapses, including the collapse of the electron is similar to a photon, but it's not in free fall. That it has no, you never talk about the velocity of an electron unless you're not talking about the intrinsic velocity of an electron. Although it does have an intrinsic angular momentum, which is the motion component, which contains the time component. So the electron and the photon are related in that they're pure energy particles, whereas the proton is not. The proton is a unique particle. And all of this is to lead into the geometry of the photon, because that's where we get the collapse of the wave function. It generally is referring to light transmission, which essentially refers to a photon, as can be proved, because it can be proved that energy is quantized. Therefore, there is such a thing as a photon, because that is a quantum of energy. Another interesting question, which I'd like you to ask yourself, is the electron quantized? It would have to be. And the reason it would have to be is essentially it's composed of photonic. And I prefer to leave it at that, using photonic as a noun. That it's a class noun, where the electron is a photonic. And the only difference then, you could say this, the only difference between an electron and a photon is that the photon has a velocity that is what we would consider impetal velocity, because it's not behaving as a particle. What I want to say is that it has intrinsic velocity. But that's not quite true. Where does the photon get its velocity? This is the correct way to solve for the collapse of the wave function, because we're essentially asking the question at the other end of the velocity problem. Because what's happening when the wave function collapses, you're talking about the spherical surface of a photon. As it's propagating in space, it has a spherical wavefront, which means it's propagating spherically in space is the only way we can retroactively state that after we've measured its passage through space. It can be proved. Christian Huygens proved this about 300 years ago. It's the basis of optics, is that a photon, just to keep it simple, propagates spherically. But what do you mean propagate? It has a velocity, and it should be called a speed because a velocity has a linear direction. You could say that the photon has a velocity, which implies a direction, as long as you're saying it's a spherical direction. Because when it propagates, it is essentially manifesting its particle nature, but with a loss of one. It's got a different degree of freedom that's spherically defined. Generally speaking, the origin of a photon is an electron. Only I believe in all cases, it's not an electron such as is something you could draw as a particle. Rather, it's the electron in its most natural state. It could be phrased this way. One of its two states. An electron can exist outside of a protonic shell, but where they're mostly found is in a protonic shell, where it's not an electron, it's a shell. It can be proved that they're the same thing, except they have two different manifestations. Without the presence of a proton, the electron is there, and so it is called a particle. It can be fired from a gun. An electron can travel through space with a Newtonian velocity, so that it maintains its intrinsic nature as an object. It's very strange to call it a particle because it's so much different from what might be called a real particle. Only the proton is a real particle because a particle has to be defined in space, whereas the electron does not have the property that a proton does, such that it can be said to exist in space in the same way. Because the proton always is the center of a proton-electron system. When a proton and an electron have the correct proximity, the electron changes state. When it's not close enough to the proton to change state, it's basically a particle that instead of having a center has a locality, which is a very strange quasi-center, because you have to say it has a presence in space because it can be fired from a gun. But when it approaches a single electron, when it approaches a proton, when they get to a certain known distance, it's about 1 femtometer, the electron changes state by changing direction with respect to the attractive force, which would have to be it's measurable linearly because they each have a center. But what can be shown about the electron is that its center is not at all like the proton, although it's related, because when the electron gets close enough to the proton, actually 1 femtometer, it goes at a right angle to the gravitational force, or the magnetic force is probably better said. It's actually, you could say it either way. It turns out that by approaching the transmission of light through space in this way, by beginning with the electron-photon relationship and the electron-proton relationship, it's then possible to see directly what's happening geometrically. Because in a simplex hydrogen atom, which is simply a proton and an electron, the electron is occupying the space that is perpendicular to the force field. The force field essentially comes out from the center of the proton. However you construe out, it's generated from within the proton, but it can be thought of as a harmonic. It's simply a vibratory manifestation in space. But the way the electron manifests the presence of this force field, which is coming out linearly, but it's spherically linear. It's coming out as a straight line, so that from any direction, an electron heading toward it will head on a straight line. But you can see that straight line could be in any orientation, and it's only the presence of the electron that picks out the straight line, which otherwise is a spherical straight line. I hope that makes sense because of what I'm going to say next. If you picture that force field as a spherical straight line that has a surface, the electron occupies that surface, which is perpendicular to the force line. So the line that comes out from the center is perpendicular to the surface of a sphere. Ruđer Josip Bošković proved that before the electron or proton were discovered. And it's ambiguous whether he was talking about a proton-proton or proton-electron relationship, because his force curve describes either one. The proton-proton relationship is invert in a way, and it occurs at a closer scale, which is why the protons bind together at the center, but the electrons are always outside the protonic center. And the number of protons dictates how the force field is manifested from the center, which you can see occurs in waves. It's a vibration in space, which makes what Bošković proved is that the proton makes two force fields. And at the boundary of the force fields, it changes from attractive force to repulsive. And that occurs both for the electron and the proton, but in a strange inversion. But it's still the same curve, and it actually is a curve. You can plot that curve. So that's the relationship between the electron and the protonic force field, which is the proton. That's what a proton is. It has a repulsive force field. That's why the electron never collides with the proton. It physically can't. It's been tried. It can't be done. The electron will not. It's interesting to notice that an electron cannot collide with another electron due to there's a certain exclusion principle that form of particle obeys. So all of this is leading up to a discussion of the photon, which has nothing to do with the proton. Although there is a most interesting exception to that. Protons can emit gamma photons, the highest wavelength of all photon wavelengths. I'm sorry, it's the highest frequency. It's the smallest wavelength. And the reason why it's a gamma photon that's emitted from a proton, it's rather difficult to make the proton do that. But it is known to occur, for instance, in a fission or fusion explosion. And gamma rays are dangerous because they're so high frequency that refers to its energy level. Frequency refers to energy. So that's the energy component of a photon. It can come from an electron, which of course is pure energy. And the proton is not thought to be energy at all because it doesn't manifest as energy. What it manifests as is a point in space. That is, it has a point center. The electron does not even when it's a so-called particle. And it can be shown, according to my geometry, that it does have a point, but not in space, which is a very strange thing to say. So now let's look at the photon so we can see, first of all, how it detaches. A photon, first of all, should be thought of, and I want you to think of it this way, as going into free fall. Because it remains as a particle, even as a spherical wavefront. But in order for it to remain as a particle, which will describe exactly why it appears to collapse the wave function when it's absorbed, is because it's not in space. And that's the major breakthrough insight that I don't believe anybody has been able to see. This can be explained geometrically, and I will show you mathematically also that this actually is computationally correct. It perfectly describes entanglement. And I'll show you why that's the case as well. All of this is exactly as Paul Dirac predicted, that if you can explain the collapse of the wave function, which is the absorption of this giant sphere of light, a photon expands spherically. That's actually counterintuitive, because wouldn't it go through both sides of the sun? It does seem to have a direction, but it can be shown that the surface is spherically propagating from its source, even though it's actually as a cone, because it's not going in every direction spherically. It simply isn't. Although even this is something that I probably should study a little bit more. But it is known. Oh, everything I'm saying is true. It's just very, very difficult to visualize, because we don't see light when it's between emission and absorption, which is called transmission. So it has three critical states. One is emission, when it detaches from its source, which we will disregard the proton for now because it's unusual how the proton emits a gamma photon. It has to be, there's violence involved for it to do that, but it can be forced to do so. So the proton also can emit a photon, they just don't. They ordinarily don't. But electrons are constantly emitting photons. it depends on the situation. We're really talking about the sun, a star, for instance, which is constantly emitting photons, obviously. Well, those are coming from electrons. That's worth looking into, but even though there's much more that really should be said in order to complete the picture, this is one reason why nobody's ever solved the problem. It really is difficult to visualize. But I think you understand that when light reaches us on Earth from the sun, it appears to us to be coming on a straight line, but the photons only appear to be going on a straight line. They don't go on a straight line. They go on a spheric trajectory. And once the photon reaches Earth, for instance, you could either say your telescope, but it really is where the photon is finally absorbed, not just transmitted through the telescope or your eye. It's where the photon is absorbed, which is a very strange thing to try to compute in terms of vision, because you know the light goes in through the pupil in your eye, and then it's absorbed at the back of your eye, but it's transferred into an electrical signal physiologically, because it is energy. So what happens, for instance, when it lands on a CCD, I want to say pickup, what's the word, a receiver, where or it could be film, where the photon changes the state of the plate, whether it's electronically, as in CCD, to either activate a pixel or leave it unactivated. That's how CCD works. It's basically the photoelectric principle, if I'm understanding that right. You're inducing a physical reaction in a surface by the action of the photon, which is a photograph. So that's the absorption of the photon. How can it be said that that wave function is collapsing? It's because it's propagating spherically, and in order for it to appear as a point, in other words, to hit a surface, it cannot do so as a sphere. It has to do so as a point. That is a quantum. And what that means is that the quantum, as it's absorbed, has a surface. It still has a surface. But if it's a spherically propagating surface, even at local scale, when the spherical surface makes contact, it'll collapse. It doesn't necessarily have to be a very huge radius, but any radius, it shouldn't be able to collapse so fast. Unless it's just, if it were actually a particle that had Newtonian motion, so that it was traveling on a straight line because of its impetal force, it would arrive as a particle, but only a particle can do that. The photon does not travel as a particle. But retroactively, we can say that to the proportion that it left its source as a particle, when it's absorbed, it is that same particle. And the collapse of the wave function is an attempt to explain what's happening in between, because it is not traveling as a particle. If it were, it would be because of an impetal energy. That is, it was fired. But the photon is not fired on a straight line. that is contrary to how we are hardwired to think. We literally can't see that. I'll show you how you can force yourself to see it. Where is the spherical surface? It's not in space. And this is actually going to the nature of space-time, that photon is traveling at the speed of time. It's manifesting the speed of time. Can time have a speed? You could say it that way. And what's happening is not that the photon has its own speed. It's not being fired. But if you thought of it as being fired, it would be the firing of an expanding sphere with a surface, which is the right way to think of it. Really, when that photon detaches, called the evolute of a sphere from another sphere, and that can actually be plotted. You have to know what you're doing, and it can't be done with linear mathematics, but it can be done with spherical mathematics, and I'll be able to show that to you later. But without going into the mathematical support for the geometry, we're talking about an expanding sphere. The strange thing about this expanding sphere is, if you think of it as just without any limitation, that this sun actually was just an electron that gives off a pulse, it would, that's actually not possible, but it's one way to say it. That's why this is a paradox. It can't actually be described until you force yourself to realize that you're not talking about space. We can't help but think that photon is traveling through space. It's insane. It's insane to us to suggest that photon is not traveling through space, because it is. And I would say, yes, it is, but not with Newtonian force. It doesn't have a velocity. It doesn't have a velocity. So you have to say it in one of two ways. Either way is going to sound insane, but if you can conjugate them, you're going to realize that photon is not traveling through space. And here is how you can prove that to yourself. It's with the combinative use of the two fantastically profound terms, entanglement and superposition. If you fully know, as I do, what superposition is, and you can fully understand also what entanglement is, you'll be able to describe the flight of the photon as it's propagating in space, its transmission, rather than its absorption or emission. There's emission, there's transmission, which is, we say it travels at the speed of light. Well, it is light, so it's traveling at its own speed. Can you honestly say that is the photon's own speed? How does it know? How does it know that that's its speed? Speed relative to what? If you keep asking yourself these questions, you may or may not see a pattern, but I can tell you that there's a key that unlocks every aspect of this paradox, no matter how you confound yourself with paradox after paradox after paradox. The one piece that's missing in the geometry, the geometrical realization of what's actually happening, is that you have a particle that is superpositionally entangled. And here's how you can know that. Not only is the photon energy, it's a specific construction of energy. And that's easy to say. That may not make sense. Why am I saying that? That may sound like I'm not saying anything. It's the fact that the photons reconstruct where they're from. That's why when we take a photograph of a planet, that it looks like the planet. Well, it's those photons that imprinted that information that's actually from the planet, right? Same is true of a star, right? The same is true of anything on Earth. The photograph is due to the photons having transmitted information. And that's the term that I want you to glom onto right now. That the photon is an information packet. Without going into, that's obvious, that's true, but it's hard to explain how in the world can a photon have so much information in it. It is an enormous amount of information that arrives in light. It's not just a shower of particles. It's a coordinated wave state which reconstructs itself. But we think it's reconstructing itself by quantum processes. What does that mean? What it means is whatever it was when it left its source, it's still that same thing. It's not changed. It hasn't changed at all. In fact, the only thing that's changed about it in its transmission state, as it's transiting from source to destination at what we call the speed of light. Once it arrives, the only difference in its being a particle at its source, when it detached, when it evoluted. Now when it's absorbed, it simply de-evolutes. And it simply reverses the emission process. So that you could say the emission of a photon is the anti-collapse of the wave. You would say it's the generation of the wave function. Well, what was it before it was the wave function? It was a wave function in another state. It was in the electron in this case. So when it's emitted, it decollapses. What does that mean? Well, what it means is we have a relationship between the source and the destination, that there's no change in that object. And it is an object, it is a particle when it's emitted, and it's a particle when it's absorbed. But in between, it's never a particle. That's the quantum paradox, is what happens between two states. In this case, it's a time-space transition. So it changes time state, and it also changes space state in terms of position in the case of space. What in terms of time? It's changing its state in space by changing its position, which has a linear trajectory the way we plot it back, because it actually tells the direction that it came from. So it even remembers its direction that it came from. So that when you point the telescope at a star, it takes a photograph of the star where that star, you see that star where it is. Is it actually there? We know it's not. Positionally. That's the background of the collapse of the wave function. That wherever it came from, it's not actually coming from what we see. Because the actual position of that source has moved. hasn't it? Yes. And that's actually quite profound and occurs in the Quran and in the Book of Enoch. And that's enough. So I hope you have seen that I haven't finally concluded though. So I'm going to wrap this up by showing you what it means to be superpositionally entangled. The photon, when it leaves its particle state, which only occurs at a tempuscule. So it's actually a continuous transition, but the way we measure things, it can't be continuous, because if it's continuous, we can't measure it. It has to be positionalized so we can measure it. Because we're positionally oriented creatures, we're not oriented in time, we're oriented in space. In order to measure things, it's contextual. So the photon, when it detaches, begins expanding as a sphere. This is just as paradoxical as saying that it's going on a straight line. It's actually doing both, which is even stranger to say, but hear me out. It expands as a sphere from its source, the photon does, at the speed of light. So that means that it's going to hit everything in the universe relative to its source. The one thing it won't hit is its source. So it's a vibration from the source. It's a vibratory effect. It's a pulse through space, isn't it? That's not true, because a pulse would attenuate in strength. This does not attenuate. It's in free fall as a particle in all directions. And what that means is that it's a particle at every point on the surface of the sphere. It is that particle, which means it's entangled with itself. And that's superposition. It's the superposition of state on a sphere. So that what we think must be a particle is, in one sense, it's the whole sphere, is that particle. But actually, once it's captured, once that sphere expands and it hits something and is absorbed, it's still that particle. So you have to be able to do a double mind trick. That while it's traveling as a self-entangled particle. One problem is the word entangled. That's not the right word. It's borrowed from the logical term entangled. But it's not entangled in the way we normally use that word. That it gives the wrong impression. The correct word is coordinated. It's coordinated. But it's not coordinated in the sense of a spatial ordinate. It's coordinated in time. So that even though it appears to be expanding as a sphere in space, it's not doing anything in its time dimension. It's still a particle. In other words, it thinks that it's just falling to the edge. Well, what's driving it? What gives it that speed? It has to be the speed of the medium. The particle itself does not have any speed in the Newtonian sense, because there's nothing that's firing that thing. It basically is forced to detach from its system. But being energy instead of matter, which is a proton, being energy instead of matter, it has a different characteristic in space. It's not spatial. It appears to exist in space. You could say that it appears to exist in space. That is, the photon does. The electron does. It appears to be, it does assume a particle form because it's a quantum. So it has to have some kind of position, but it's not a quantum of space. The proton is. It's the quantum of space, because it's the only thing that exists in space, and the reason we know it exists in space is because it bends space. It affects space. It affects space with a force field, which is invisible to us but not to the electron. The electron sees that force field and occupies it, which is perpendicular to the force line. So now you see why energy is perpendicular to gravity. And so the collapse of the wave function is essentially this piece of information, which is a particle. And to us, it looks like it's getting bigger and bigger in radius. But it's not. It only seems like that retroactively after it's collapsed. Well, what is the collapse? It's the arrival of that sphere where what it's been traveling through appears to us to be space, but to it is a component of what it's actually traveling through. And it did not experience time because it's traveling at the speed of time. Time is part of a rate, isn't it? A rate of what? We'll have to go into that in the mathematics and geometry, when I'll actually show you how to construct this space from a mathematical basis. And then I'll show you the numbers. The strange thing about the collapse of the wave function that I think is most peculiar and most telling, and Paul Dirac somehow saw this too, but I can now prove why Paul Dirac said that if you can solve for the collapse of the wave function, you'll solve every problem there is in quantum mechanics. It's because the nature of the photon in transmission, as manifested by its absorption characteristic, which is that it is always as a particle. It's not captured as a wave. A wave cannot be captured because the wave, in order to be captured, to become part of a material system whereby we could measure it, it has to collapse. It has to stop being a wave. Well, what does that mean? In the case of the photon, what it means is that the information that's in that particle is still coherent, which means it never changed from being a particle. So the surface of the wave is a super-entangled particle. I just invented the term super-entangled, which would mean superpositionally coordinated. We can't visualize that, but we can prove that that's what happened. So that physically defines what is meant by the collapse of the wave function. There is no collapse because it's not a spatial phenomenon. And that also explains why it seems to violate light speed. The exact opposite is true. It establishes light speed because something is going at that speed, which is only a photon. Only a photon does that. And when it does, it's manifesting the other dimension that is non-spatial, which is not the time domain. It's the energy domain, which has time built into it. And I can show you now geometrically what time is. It's part of a conjugation where frequency implies time, but wavelength does not. But a wavelength is the contradiction. A wave does not have length. That's artificial. A wave has no length because it's non-linear. And then we're going to show a lot of this. You'll be able to see a lot of this much more clearly when we get down. I'll show you a diagram of the quantum I'll show you a diagram of the quantum of energy and the quantum of space. They're slightly different, but Ruđer Bošković discovered both of them. And now we can compute what's inside the quantum, which sounds paradoxical. It's anti-paradoxical. I figured out the solution to the paradox form, which has enormous repercussions, because that enables us now to get the quantum of gravity and get Einstein's unified field solution by gaining the universal reference frame. These are monumental discoveries, any one of which should get some kind of prize. I don't expect to. I'm not even sure I would deserve it. But that is what prizes are given for, are discoveries of this level. Actually, we don't have a prize for this level of discovery, because this ends up solving everything. And when I say everything, thank you for tuning in. I hope you continue to tune in through Thanksgiving and for as long as I remain on this planet. I have a great deal of fun making these videos. It's extremely good for me, and I may have exaggerated when I say I do this only for me. I don't mean to say that. I hope I didn't say that. I do it for me, but obviously I don't do it just for me. And I wouldn't be a scientist if I were doing it just for me. And I also have a higher purpose in doing this at all, which I might be just for me, but I hope it's not, because it leads to some very profound insights into how this universe is manifested. So thank you for tuning in. Keep looking up. We'll have more later, but I hope I've given you an insight into the collapse of the wave function, that when that sphere finally hits your eye, it's not a sphere. It's a particle that only appears to us to have a spherical wavefront because that's the only way we can describe it. But that's not how the particle describes itself during its flight. It remains a particle that is simply falling. It's falling to the edge. That's anti-gravity, and that solves the monopolar nature of gravity, which has stymied everybody. They're looking for quantum gravity because they can't find the other pole of magnetism. The proton exhibits magnetism, and the electron exhibits electricity. And that's the relationship between magnetism and electricity. Electricity is motion, which is only measured in time. It's not measured in space. And that should, I hope that gives you a clue to the collapse of the wave function. A lot of these are going to sound like enigmas or even koans, but I hope I got you a direct insight. I'll give you more so that you will. If you keep trying to see this sphere, which is it's not in space, that's the key insight, and your mind has been trained not to accept that, but that is what's happening. There is another dimension besides space, but it's not time. It's another space that's part of space. So space is nonlinear, but it has a characteristic that is not positional. And the photon manifests the existence of that other spheric dimension. I proved that those two conjugal dimensions, space and energy, are two component domains. Therefore, the conjugation of space with energy is a four-component linear number system. Because there are four linear numbers, but the internal construction of the linear numbers is not linear. Both numbers are binary. They're binary numbers. And that's the quantization of the universe, making it finite. And in order to prove that, you have to be able to conjugate the two spheric infinities. So I hope that tantalizes you, and we're coming up on an hour. Thank you again. That I just told you the basis of how to geometricize and even mathematize the collapse of the wave function. But you can tell why nobody has ever been able to see this. It's almost impossible to maintain the vision in your mind because you're basically divorcing yourself what you know space is from your visual perceptual space. But don't forget, we only see a flat screen image. It's only motion that gives us the ability to compute depth. If you think about that, you'll realize that you simply cannot see this other domain because it's composed in a space that has nothing to do with position, but has everything to do with motion. All right, so thank you again, and keep looking up. We'll be right back.